All right, so just before we jump into Cinema 4D, we're just going to take a quick look at this diagram just to get used to a couple of terms that we'll be using throughout the project. And it's also just a way that we can get a quick overview and understanding of what we're going to be replicating. So first off, this silhouette should probably be quite familiar. It's a plant with branches coming off and then leaves. The first thing that grows out of the ground, obviously a plant has roots and everything. We're not going to be dealing with the roots. We're just going to be dealing with the sort of the broader stuff above ground. So we've got the main stem here that'll grow out the ground and move towards stuff. That is called tropism, and that's something we'll be dealing with later. The other part here, obviously the naming, in terms of naming, is called the main stem. And that's just the bit that it starts to grow out and then other things branch off it. These buds kind of form on the stem, and then they'll turn into sometimes flowers, fruit, but with what we're dealing with, branches and vegetative growth. So that's the first main stem. Second comes the lateral shoots and branches. So they'll branch off the main stem and they'll follow, a similar rule set to the main stem in that they'll follow light, or they'll avoid objects, they'll stick to a wall, that kind of thing. And then off that comes something. Well, first of all, it's obviously a leaf is going to come off this, but the first thing that actually grows out is something called a petiole, and that's literally the stalk that attaches the leaf to the stem or the branch. And these come out of these little buds, basically. We're not going to be creating the buds because we don't really need them at the distance we're going to be viewing this rig. And these petioles grow out. They have the leaf bud at the end of them, and that grows at the same time. And of course, we all know that these are the leaves. There is something to think about, and that's at the end of this it's called the terminal bud. And we can think of all of these lines as being a trail left by a particle. So our terminal bud is basically the tip of an XP trail object that we'll be creating. Okay, so I just wanted to give a brief overview. That was pretty brief. Let's jump into Cinema 4D. Okay, so here we are in a fresh C4D scene, and let me just bring on that diagram again, just so I can refer to it. Now, we've talked about this in general terms, like in the real world, how this behaves, but we haven't really talked about how it's going to be relevant in X-Particles or in a particle system. So what we have here is we have these separate elements, as discussed. We have the main stem, a branch comes off it, or several branches, of course, will come off it. And then we have these petioles, which are sort of sub-branches, if you like, of the same branching system. And then we have these terminal buds. The terminal buds you can think of as a particle, because what we're going to do is we're going to have a particle move up through these sort of these paths defined by a few sort of different variables. And then at a certain point, based on a few parameters, it'll branch off, and it'll continue until it stops based on a parameter, or it would continue forever if we wanted it to. Now, X-Particles is nice and helpful with this because we have something called the xpBranch modifier, and that will actually get us going most of the way there in terms of the general shape, but then there's some extra stuff we're going to add in to make ours a bit more interesting. Okay, so let's start building an X-Particles branching system, and then we can come back to this again if we want to refer to it. Okay. So first off, let's start with the system. So let's add a system, and we're going to call this, let's call it growth actually. IV growth. And we can color it with whatever we like. I like to just give them a different color so it's just something other than the default. Let's give it a nice natural green. Well, that's kind of a horrible green, but anyway, we'll leave it. Let's go for a branch modifier. So we're going to add one here, and that's in the generate because it's actually going to generate new particles. So we add the branch modifier there. Now, if I press play now, we've got a default emitter. We've got an xpBranch in the scene, and I press play. It's kind of hard to see what's going on. But so what I'm going to do is I'm actually going to reduce the source particle to 1. Let's go for a defined emission. And also let's have it go vertical. So we're going to go y plus. C4D is y plus coordinate system. So there we go. It's a very small particle at the moment. So let's also make that a little bit more interesting looking. Let's go for let's do arrows. Arrows are good for seeing direction. So if I press play there, and we'll see an arrow firing off. Obviously, it's not following the angle of the particle. We can change that if we go to set rotation data, tangential, and there we go, off it goes along its path. Now you can see it's jittering along, and you can see it's sort of moving along like that. Quite interesting, but you can't see any branching going on. There's no particular extra thing. To see branching, there's a couple of things you're going to need. We're going to need some sub-branches in our xpBranch modifier, but also to be able to see it clearly, we're going to want a trail object. So we're going to add a trail. If I have this XP emitter selected, I go to the X-Particles menu and I can go to generators, add a trail. I can just drop that into our generators sub-null there. Now if I press play, we've got a nice trail coming behind it. There we go. Cool. So that's nice and simple. Now we actually want some branches, because the xpBranch object has a bunch of settings in it, and by default, it will not produce any branches on your particles because you haven't added a sub-branch group yet. We'll get onto that in a second, but you can see here we have this max time, and if I drop that to 10 frames, this is the length of the well, you can't really call it a branch yet, this is the stem. So if I go to 60 frames, you'll see it'll go on. There's a bit of minimum time there as well, so it won't stop before that point, but it's somewhere between 60 and 10 it's going to stop. So you can see there it stops. We can do that by distance, and that's actually probably my preferred way of doing it. So once it reaches a certain distance, if I do let's do 200. Let's make it both 200, so it'll be exactly 200 when it hits there. There you go, that hits 200 and stops. Okay, that's pretty straightforward stuff. You've seen this kind of thing before without a branch modifier involved. Let's have it move 600 units with a minimum of say 300. And you can see here it's got this bending parameter, and what this is doing is adding waviness, because obviously branches and growth systems tend to move in a non-linear fashion. So we're just going to go back to the branch object, and you can see I can tell it what frame to bend in. So it's every fifth frame it's going to bend, and the bending isn't particularly obvious right now, but if I make the bend deviation 30 degrees, you'll start to see it really, each fifth frame it's going to bend 30 degrees. Now I can actually say it's not exactly 30 each time, it's actually between 0 and 30, because I have this minimum here as well, similar to the minimum distance. So I press play, and that's now 30 exactly each time. So each time that's moving 30. Obviously that's quite unnatural and inorganic, so the minimum bend deviation being 0 is a good one. And then the bend in time is also a bit too consistent, so I'm going to add a little bit of variation with 5 and 3. And there we go, we get some motion where it kind of ticks around, changes direction, that kind of thing. And you can play with those parameters depending on what kind of plant you're growing or you're generating. Okay, so that's reasonably interesting part, but the more interesting thing is when we add a branch, and you can see we've got these quick tabs here. So we've got general, that's where we've just set up all this stuff. Then we have this branching one. Now you can see there's actually a bunch of parameters here grayed out, and if I add a branch object, I won't hold control or command down, we add something called an xpSubBranch object, and what this is going to do is this is actually going to activate all the branching settings in the item above it. So we'll go back to our xpBranch, and now the branching from this level has been activated. So what that means is that from the main stem, we're going to branch off a bunch of extra branches. So actually I'm going to call the xpBranch stem, let's call it main stem. And the sub-branch, it's actually correct. So it's a branch. We could call it so the shoot. So we could say shoot. There we go. And if I press play, we're going to start seeing some interesting stuff. And there we go. We're going to get some branching. And you can see they're kind of longer than the source thing, so it looks kind of weird. But you can set these to a much lower setting like this, and they'll stop when they reach that setting. And you can see we're starting to get something a little bit more interesting here. Okay, so that's the basics of a branching system. And like I said, you can go back up to the main xpBranch object here, and you can set a few parameters. Okay, so we have enable branching. We've enabled branching. You can actually just toggle that off if you just want to go back and deactivate that level. So that's fine. But also we've got these other settings, branching from base. That means basically it'll start branching immediately from the very base of the original emission, the main stem. Branching from tips, probably a bit more, it'll actually emit from that top particle there. It's kind of doing it anyway already, and so it's not really a problem. Now there's a bunch of other stuff in here. So the branching is quite consistent at the moment. If I take out all our variation in the bending, so if I just press play, you'll actually get a much more sort of visual, accurate visual way of seeing the branching. So if let's say go back into this xpBranch object in the branching. If we actually set the branch deviation to exactly 30, so basically minimum and maximum are the same, they're at 30, I press play, that angle there is going to be 30 degrees. Now they're also bending a bit, so if I go into the sub-branch or the shoot, and I turn the bend off completely, so that they're also straight, you can see these angles here are 30 degrees. Now some of them might not look 30 degrees, but that's because they are rotating around. Obviously they're emitting at different angles. Okay. And also quite consistent. So you can see that they come out there at sort of pretty regular intervals, and that's also set by the branching stuff up here, and that's a variation here. And we can start adding in some variation of when they emit. So like that's basically what we're talking about there, is the spacing between each petiole, or at this point it's actually the branch. So between each branch, but for the sake of argument we can use the petioles basically. So that's this gap here, here and here. We can add a bit of variation into that. It's not a consistent exact dimension in real life, and that natural variation is what sells the growth system. Okay. We also have the number of branches, the max number of branches. So if I say we only have one branch, we'll only get one branch, and then it won't add any more at all. And so this is the max number of branches. That's like a global cap on this branching system. There will never ever be more than 1,000 branches, and that's not too much of a worry right now. We don't mind about that too much. But this one, number of branches, this will actually, it's the number of branches generated each time. You can see each time it generates a branch as a set of 10 coming out of there. Now we don't want that. That's perhaps more suited. You can see that's almost like a hair of like a barley ear, where it's a lot of them are coming out of the same location. We only want the one, but I just thought I'd introduce you to a few settings of the branch modifier just in case you weren't familiar. Okay, there is this other tab called spawning. I don't think we're going to be dealing with that. Maybe if we did some sort of flowers and fruit and things like that at another point, but we don't need to worry about spawning just yet. Okay, so we've got this one set of branching coming off. Now we know that the main stem is going to go and do its thing, and then we've got these secondary branches coming off, and actually I don't want them to be quite as often as that, so I'm actually going to make the gap branch in 15 frames. There's way fewer of them. We might even extend this out later on. And I'm also going to let them go on for much longer, so say 300. Not too much different to the main stem. The main stem's going to stop at a certain point, and then because it's an ivy obviously its branches go off as, much further than the main stem even, and you end up with a huge sprawling plant, of course, and that's what we want. So I'm actually going to have the length that they're set to quite high. Let's give ourselves some more playroom. There we go. Okay, and you can see there actually the main stem has actually stopped. Let's give these some better colors. So let's do this with groups. So I'm going to go to the emitter. I'm going to add a main group just to start things off. This is particle group 1. We'll call this main stem. I might use my full stop system that I like to do. So I could even just say main stem group actually. So it's just so we can identify these nice and quickly when we need to reference them. So main stem group, I'm going to set that to the main stem. If I go back to the general tab, groups affected, And it's going to be main stem. Actually, we don't need to worry about that right now because it's going to actually affect all the groups equally. So I can leave that empty. But what I do want to do is I want to add a separate group that will separate it from the original group. So let's duplicate that group just because I'm lazy like that. And let's call this one shoot group. I'm going to call it shoot group 1 because we're probably going to do a couple of levels. Because I'll just go back to this diagram again. Some of these plants, and ivy is probably one of them, is that once these, sometimes you'll get a bud that actually branches off this secondary branch, and you'll get another separate set of branching from there. So we might do two levels. So I'm going to call it 01 for now, and I'm going to change the color. All we're doing right now is just setting up a basic growth branching system. So let's go to our sub branch and let's set the branch group to shoot group. Now that should change color when we see it. There we go. And you can see the main one finishes and then we have a bunch of extra branches coming off. Now let's add back in our deviation, our sort of bending. Let's just try some different settings. And we can change these on the fly, of course. That's the beauty of this system. So it's going to bend between 20 and 10 degrees every every 2 to 8 frames. And in our sub branch, that's that one. And sub branch is here, max bend deviation. Let's do a similar. And there we go. We're getting some nice natural branching. And already you can kind of see, it's a bit like lightning, fork lightning. You can see that we're actually getting an interesting looking shape or structure for our growth. Now let's just add, I think I might do a couple more sub branches, shoot systems, or just one more of those. And then we'll do the leaves and the petioles. So I'm going to, holding control or command down, I'm going to actually duplicate this one because I actually want the settings to be pretty similar to the ones we've already got. And what I'm going to do is I'm going to call this one .02, call that one .01, and then of course we need another group. Oh, change the name automatically. I'm just going to copy paste that, change it to 2. Let's drop that into shoot group 2. Let's change the color. Press OK. And now let's see what's going to happen. And you can see just by duplicating some of the things we already have in the scene, we actually get a pretty complex looking branching growth system. And I think we might reduce the number of them overall later on, but we don't have to now. We can set the basics up now and then tweak as much as we like. Now, if I add another sub branch system, you can always do this, by the way, from the object itself. So whichever branch object you've got, whether it's this XP sub branch or the XP sub branch sort of modifier itself, there's always this button here, add branch object. So I've got this one selected, add branch object. I'm going to call this one sub branch Petiole. And that's as we've seen before, that's this part of the growth system where it comes off the branches and then goes out and buds a leaf at the end of it. Okay. So let's make this one a lot shorter. So currently it's the length method is based on time and I want it to be based on length. And we might change stuff like this, like I said, a bit later. Let's say minimum length is 15, maximum length is 20. That's roughly realistic values actually, but based on the ivies I've seen in my garden. And if I press play, let's just see that play out. And we've got you can see we're getting new particles added based on that last branch, but they have no group. So they're back to that default green color of the main stem. Let's duplicate that one. Call this Petiole group. And there's no number after that one because that will only be the only one that is a petiole. Now what colors have we got here? Let's go for a yellow at the end. Nice. It should be really clear to see these. And I'll tell you what, I'm going to actually change it from an arrow to a square just because it's getting a bit cluttered. And we'll talk about size and stuff later on. Oh, and now I need to assign that group, of course, to the last sub-branch object. Press play. And there we go. We can see them at the end of these little branched off nodes, or petioles, I should say. And let's also do something with the trails. So currently we have, this is thinking a little bit ahead, because I've done things like this before, and I know that I've wanted to address different parts of a branching system with different materials or different displacement options and all that kind of stuff. And the problem is that say if I now put this into which we will do later, but I'm going to just, for now, let's just create a spline mesher. And if I drop this spline into there, it gives us this nice shape, just to make it a bit more aesthetically pleasing. If I do this, you're starting to get an idea of what we're going to be doing later on. I'm going to turn the joining off. We're not actually going to have the joining. Let's do 2. And you can see there's already a problem here in that some of the petiole sections have a size issue with the next level down. Now you can use the radius of the particle to sort of sort that out, but I like to be able to address the trails completely separately and allow for, individual addressing. And how you do that is you create multiple trails per group, and then you just say group affected and then the main stem group. And there we go, we get the main stem. Let me duplicate this one, and let's clear that out. Just duplicate that a couple of times. Shoot group 2, and last of all, petiole. And in the viewport, it'd be handy to be able to see these levels as well. So what I'm going to do is I'm going to, first of all, let's name these. So trail, main stem, shoot 01, I believe that is. Yep. Shoot's probably plural, but let's leave that for now. And then petiole. And to keep things organized, because I know I'm going to have a few of these other generators and spline modifiers, spline meshes and things later on, creating subfolders is a fairly good practice. Not always easy to be disciplined enough to do it, and I'll admit that it's not always easy, but it is kind of handy if you end up with lots and lots of stuff in one system. So I've got the XP trail set up, and now I want to give them some different colors. So I'm going to go to the basic tab. Same with any object in Cinema 4D in the viewport, it'll have a basic and display tab. Turn it on to just activate use color. In fact, we could do this all at the same time actually. Click that on, and now let's change these colors. So let's go for we could do, there's plenty of different colors we could do here. Let's mirror our group colors, and let's go for green for the main stem, a contrasting one for the next. So we could go for maybe a red or even a pink color. And in fact, we could actually use the color picker to actually grab the color off of our group. So if you just grab the color picker, and we'll choose it directly off the group icon there. Sort of a quick and simple way to do that. And now you can see our branching system looks a bit more identifiable, and we can follow the branching system. And we could even not have the arrows anymore. I mean, it's going to be useful later on for the leaves, which is the petiole group, but the arrows on the other ones aren't particularly useful now. Now that we've got the trails following, we can see the direction that they're going. So I'm going to change it from arrows to squares. I could even change it to none, but I like to be able to see, exactly where the leading particle is. And there we go. So that really is the basics of a branching system in X-Particles. Now, we obviously want to go several levels more complicated and do some interesting things. And one of those things is actually to have it collide with objects and follow their surface. So this is the basic of the branching system, but now we want to move on and add sort of collision and a way for it to creep up a wall or kind of as you've seen the scene with the arch and the church ruin. And to do that, we need some geometry. So let's start with some simple stuff. Let's go for a cube. And let's make it a little bit wider, like a wall. push it over to there, and lift it off the ground. Now this is only going to be our very rough proxy geometry to start with, and we'll move on to some more interesting stuff later on, which actually brings me on to a point, and that is it's a good practice to group up your colliders and things in a way that you can switch things out quite easily. So because we're creating a system where we're going to be changing perhaps the collision object, or we're going to want to use it on other scenes later on, I would drop this into a connect object. So I'm going to drop a connect object into the scene at 0, 0, 0. Then I'm going to drop the cube into that connect. And we're going to rename this connect as, let's say, I want to say climbing surface, because it's not really colliding with it. So call it the climbing surface. Let's be tidy and drop it into our other objects. There we go. That means that if we save this as a system preset, so if I click that button and save it as a system preset, it would actually include that climbing surface geometry. And it just means that it's nice and dynamic, or procedural, I should say, to be able to do that. So, okay, we've got that in there now. If I press play, of course, we've got nothing no interaction going on. There's no collider tag with this. There's no actual way for the particles to know that this thing is here. So the first thing I want to do is I actually want to have a follow surface. So first of all, let's get the modifiers open, and I'm going to use a motion modifier, and let's grab a, where is it? Follow surface. There we go. Alphabetical, funnily enough, of course. I should have known that. And I'm going to drop the climbing surface into that. Now, if I press play, what should happen is it should capture the particles. And right away, you can see our growth system, it allows it to cling to the wall. One thing I'm noticing is that the climbing kind of ends a bit too soon. So let's actually increase some of those settings. Let's go to the XP main, the main stem branching system. And I think this is going to be still probably, I'm going to leave it at 600 by 300. I think that seems pretty fair. The bending is, well, actually, let's just check. That's pretty good, I'd say. Might be bending too much, though. We'll mess around with that later. Maybe actually increase the deviation. So I just want to see this a little bit more sort of flexible there. And remember, the distance covered is obviously related to the speed of the original particles. So our look will also change depending on how fast all our particles are moving. If I go into all of them, select them all at the same time, and I go for a size of 20, we're going to see way denser branching because they're all moving at the same speed, but they're going to stop branching once they've reached, you know, a much, relative to that speed, a much larger area. So we don't want it that low. We'll probably come tweak these later, especially the petioles, because they have their own kind of look to them. Okay, so sorry. Get back to the max distances. It looks like the first set of shoots kind of end a bit too soon. So let's have a look at those. They're currently 300. I think probably quite similar to the original. Is that 600? Yeah. So let's go for a 600. We want some decent variation in those. So not full 600. So between 600 and 200, that's quite a good amount of variation. There we go. They're getting a bit further out, but they're still not quite there. We could also, should we tweak the, I want them to bend a little bit more than they are, and they're not. Oh, they're doing that kind of consistent bending on both the shoot 01 and 02. Actually, you can see I've got no variation in the bending. Let's crank that up to quite a high. See, we're getting a bit more jittery movement, and I find that it looks way more organic, which is kind of what we're after. Something I should also note is that the emitter seed actually affects this whole branching system. So if I change the random seed here and take a look at that, that's now giving us a totally different branching system or branching shape. Let's try another seed, and that'll be different. Now this particular seed has revealed an issue, and you can see the branches are actually coming away from the surface and not adhering to it anymore. So let's try a different seed again. And you can see that one's a bit better. But some of them are escaping the wall still, and that'll be because our emitter isn't close enough to the wall. So I'll just bring it a bit closer. And can you see there's actually something going on here? Let me turn off the trails for... I'm just spotting these things as we go along. And can you see how it's jittering away from the wall and back? That's because the subframe steps is probably too low. It's sampling, it's looking for the wall, or the modifier is actually looking for the particles, I should say. And if it's not found it in between a frame, it just lets it go, and then it comes back again. So we need a bit more detection resolution, I should say. And if you hit Command D or Control D, we can just add another subframe step. Want as few as possible. But there we go, let's go for 3. And you can see it's much more close to the wall. Okay. There we go, branching out nicely. Away it goes, and you can see how much it changes based on where it is on the wall as well, and where it starts. We're going to actually take control of the direction in a bit, but let's just finish off our editing of the sort of the distance we're seeing here. So we've got this second sub-branch. I think that one's going to be less, but still, because that's 600. These could be quite varied, but no less than 200 as well. Let's do the same with this that we did with the other one. Bit more bending frequency, and a bit more varied as well. Now the branching on this second one, I think it needs to be more frequent. Can you see the petioles? The spacing on them is a bit too ordered, and I'd like the internode to be a bit varied in length. So let's say branching in quite a frequent. I still want quite a frequent branching, but I also want to have some variation. So let's branch even more. Let's go for 3. Remember, we're going to have leaves at the end of each of these petioles. So this is essentially our leaf density. So we want this to be quite high. I also don't want the leaves to be stuck to the wall. So we'll deal with that in a second. Pretty happy with how that's looking. We've got the branch deviation. Now, I kind of want to force the branch deviation to be quite extreme off the main branch. It's all the shoots themselves. So I'm going to say have a max branch deviation of 90. Remember, this is for the petioles, and a minimum of 20. Press play, and you can see here it's a lot more. They're forcing themselves away from the original branch. You see that? I do like these branching systems. They look cool. You can see it's wrapping around and all over the place here. That's cool. Okay, so let's have a quick check. Branch deviation on these ones doesn't need to be quite as extreme. I think between 30 and 0 is absolutely fine. On the last one, on the leaves, the petiole, I think if we increase the bend deviation, I mean, if you can see, they don't tend to bend that much anyway, because they don't really have time to. So what we'll do is we'll actually use gravity to give them a bit of their own shape. Okay, but let's say max length of 30 actually, because in between 30 and 20, or 10, sorry. There we go. I'm starting to like the balance between these things. So what I'm looking at is I'm looking at the balance between the main shape. So if I turn these off one at a time, so I can turn that off. In fact, let's hide the emitter itself. And you can start to see our structure here. So here's our main stem, the green one. Then we have the secondary shoot system, or the first shoot system and branches. They might go on a bit long. No, I'm gonna leave that. I quite like how they roam around. And then if we look at this next one, that's a lot denser. So I think we should probably reduce the amount of branching going on here. Yeah, so currently that's branching in, I suppose every 5 frames. No, I think we'll say 20 and a variation of 5. It just seems a bit extreme at the moment, so what's the original one? I might decrease that one as well. This is all, depending on what kind of system you're developing, you'll get a feel for what looks right in terms of density. That's starting to look a lot better to me. Like I said, we're going to play with the speed a little bit later as well, so it might change the shape, and then we'll come back and ripple through these and tweak these out again. But the main thing is that we have control of each of these levels. Something interesting to know, if I deactivate one of these sub-branches, it's not going to branch below that. It doesn't just skip that into the main stem. But what I could do is I could take that out from being a child, and you watch here, and now that becomes that set of branches. And it's great, and being able to create all sorts of variations by nesting them in different locations and changing and having sibling branches and stuff like that. It's really cool, because you might want buds on this branching system as well. So maybe you have different buds coming at the same level as shoot 2 or shoot 1, and it's that cool kind of procedurality. Probably not a word. So let's go back to adding back in our petioles at the end there. And you can see they're branching off nicely. We're getting a good look at the structure here. And once we've got some direction to this as well, this is a bit wild at the moment. It's just going off the original direction of the particle and then bending and bending and bending. I'm going to give it some direction. So this might look a bit sparse at the moment, but it will get a lot denser when they have a direction. Like I said, we can tweak all of this later on. But what we want to do now, because I mentioned it a second ago, is I don't want the petioles to attach to the surface. I don't want them to follow the surface. I want them to actually be able to be free and move away from the surface. So first things first, don't let them use the follow surface. So let's use groups for this. So we're going to the follow surface groups affected. And then if I grab the picker here, I know that we need these first 3 groups. So main stem, shoot 1 and shoot 2. And then we can press play. And you'll see the petioles are free to jump out from the wall. See that? Now, they don't look very natural because they're not bending, and that's because they don't have enough time to really bend, and also their speed is probably potentially a little bit too high. We'll see. But I also want to add some gravity, but only to the petioles. So let's add some gravity. And let's make sure the groups affected is only the petiole group. Now what this will do is it'll hopefully start pushing them down. And you can see there we're getting a more natural look already. And because they're free to move, free from the wall, sticking, with the follow surface not included, they can move down and away from the surface. However, if I go to wireframe mode and we look inside, we're getting a lot of petioles actually spawning or branching and ending up inside the volume. Now we don't want that to happen. So what could we do? We could use a collider, but that will actually cause some quite aggressive jittering, because if you add a particle in right next to a collider, you can end up with some weird jittering. I prefer to use an avoid. So let's go for an XP avoid. And that's a motion modifier. So XP avoid, there we go. And make sure that's only on the petiole group again. We should probably give this a subfolder as well. I'm going to say petiole only group. I'm going to put it at the top there, and we're going to have a void, gravity, and let's tweak some settings. I don't want the distance to be too high. Give it some variation. And what that should do is that should push away our petioles from the wall and won't allow them to penetrate inside. So let's have a look. Now that looks like it is still doing it. Have we given it enough? Yeah, that is definitely still doing it. So avoid. I tell you exactly what I've done wrong, and you've probably spotted it. Being a bit slow, I told it to avoid nothing. So there's no object actually assigned here, so I'm just going to drop that. The climbing surface in here. That was a little confusing to me. There we go. And you can see none of them are now going inside because I'm not colliding it. I'm just telling the petiole particles that they are not allowed, or they should avoid this surface. And you can see that's pushing them away. Awesome. So that's pretty cool. And let's just test it on another kind of surface because I just want to make sure it's working. Let's grab a torus and stick it on the front here. Now, even if we put these two bits of geometry inside our climbing surface or inside that connect object, we'll get some unwanted behavior where, and we'll see it here, that the ivy will grow inside and around where it shouldn't go. Now, you need to create a continuous surface if you don't want that. So for now, we're just going to test this torus, deactivate the cube, and there we go. You can see it grows around the torus really nicely, and it kind of follows the topology. And if you hide the geometry, the original geometry, you can see you could actually use this as a really cool way to reveal objects, things like text, logos, that kind of stuff. It's just an extra level of cool, and it adds some real sort of natural dynamism to your scenes. Okay, so let's just go back to the wall. I think the wall's a good one to diagnose it on because it's flat and it's quite easier to see intersections and things like that. But in general, I think we're nearly there with our growth system in terms of the collision and avoidance. And what we want to do next is we want to add direction, and we want to be able to guide the particles along. And we're going to start that in the next video, and we're going to start talking about something called tropism. It's quite a simple sort of concept, and it's fairly straightforward to implement in X-Particles. Okay, see you in the next one.